Hey guys, Mr. Riz here to help you out with your trigonometry packet. Today, what we're going to do is go over kind of the basics of some trigonomic functions and making sure that we can find the side lengths of any right triangle. All right, so trigonometry all revolves around this idea of these trigonomic ratios. So this is a ratio or a comparison of two sides of a right triangle. That's called a trig ratio. The three most common trig ratios that we have are sine, cosine, and tangent, which we abbreviate sine, SIN, COS, and TAN. So one thing about any sine ratio or trig ratio, I shouldn't say sine ratio, a trig ratio is that it's all based off of what angle we're looking at. So in each one of these, we're looking at angle R. So I like to circle that here. All right. Now, when we look at angle R, we actually have three sides. The one side here is the hypotenuse. The hypotenuse is always the side opposite of the 90-degree angle. It's always the longest side. That's the hypotenuse. The side away or across from the angle we're looking at is the opposite angle. And then the leftover angle is the adjacent angle. So the three ratios that we would have for sine would be the opposite over the hypotenuse, which in this example here, the opposite side is called little r and the hypotenuse is little t. In cosine, cosine is the adjacent over the hypotenuse. All right, and in this one here, the adjacent would be little s and the hypotenuse would be little t. And the tangent is the opposite over the opposite over the adjacent, which would be little r over little s. So with this, we can set up these ratios, and with things, or I should say things, but calculations pre-built into our calculator, we can use those to find a whole lot of different things. So the first thing we want to do is make sure we can set these up. So remember, sine is opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. An easy way to remember that is SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. Some old horse caught another horse taking oats away. Just easy ways to remember these trig ratios and how we get them set up. This section is actually really, really easy as long as you know how to set it up. If you don't, it can be very difficult. So let's look at this. If we're looking at angle A here, let's label our sides. 13 is the hypotenuse, that's the biggest side. 5 here is the opposite because it's opposite away from our angle that we're looking at. And 12 would be our adjacent. So the sine is opposite over hypotenuse. The sine of A would be 5 over 13. And we're going to leave it, it's better to actually leave as a fraction. So let's just leave it like that. Cosine is the adjacent over hypotenuse. The adjacent is 12, the hypotenuse is 13. And the tangent is the opposite over the adjacent, so that'd be 5 over 12. And I think it's better to leave them as fractions since we're going to be using calculators for this whole section. Okay, let's move on to the next part. All right, so next what we're going to do is we're going to find sine, cosine, and tangent, but we're going to look at this with the perspective of angle J, and then we're going to switch perspective and look at angle L. So let's start with angle J. All right, if we're going to look at angle J, 20 is the hypotenuse, that's the biggest side. 12 over here would be the opposite, and 16 is the adjacent. So we got SOHCAHTOA, SOHCAHTOA. All right, so our sine of J is opposite over hypotenuse, O over H, so that's 12 over 20. We could reduce that fraction, but we're going to use calculators. There's no point of doing that. You make sure I'm doing, can you, okay. Sorry if you can't hear me, my voice is a little low today. Oh shoot, did I mute that completely? Oh, can you hear me better? I don't know, we're gonna find out. Okay, next we got cosine of J is A over H, so that'd be 16 over 20. And the tangent of J equals O over A, and that would be 12 over 16. Okay, now when we look at L, if we want to find the sine of L and this cosine of L and the tangent of L, we're going to go ahead and change our perspective. If we're looking at L, 20 is still the hypotenuse, but now 16 is the opposite and 12 is the adjacent. If we change our perspective, our opposite and adjacent change. So our sine is now going to be O over H, which is 16 over 20. And our cosine, our adjacent over hypotenuse, is 12 over 20. There's a nice mathematical property that you guys will learn about in like pre-calc a lot, that if we look at different angles, they get switched here, 12 over 20. All right, and then our tangent is opposite over adjacent. So if we're looking at L, the opposite is 16, the adjacent is 12. Okay. All right, so now that we know how to set this up, let's look to see what's next. How do we actually use this to find missing pieces? All right, so if we want to find missing sides, like in this example here, we can use the calculator to help us round. So what we're going to do first is we got to figure out what trig function are we going to use? Are we going to use sine, cosine, and tangent? So I like to circle my angle and label the two sides we have. We are trying to find the opposite and we have the adjacent. So if we look at SOHCAHTOA, what trig function uses O and A? We definitely don't care about the hypotenuse. It's not labeled, so we're not going to use those two. O and A would be tangent. So here's the thing. We're going to set up every single property or every single problem as the trig function. And we're going to put the angle in parentheses equals, and then we'll have to figure out what side ratio we're going to be using, side over side. All right, so we know we're going to use tangent, so that's going to be our trig ratio. So we're going to say tan of the angle is 64 degrees is equal to our side. Well, tangent is opposite, which our opposite is x, over the adjacent is 11. Okay, so when it comes to solving, to get x by itself, we have to think about how can we get the 11 off the denominator, and that's by multiplying the other side by 11. There's a nice little trick here that we can do. If x is ever on the top of the fraction, if it's up high, you multiply. And later on, we'll see some more examples. If x is ever down low at the bottom, if it's ever down, you divide. All right, so what we're going to have to do to find x, we're going to say that's going to be 11 times the tangent of 64. Okay, so that's really the only math that you have to do. The rest of it is going to be the calculator to do the work for you. So I'm going to use this graphing calculator that's here. Sorry about the mess that's kind of in the way, but hopefully you can see through it. All right, there is one thing we have to do with the graphing calculator, or really any calculator we should do if you're using Desmos, is to make sure we're on the right mode. So I press mode on my calculator, and you should see that there are two choices. One's for radian and one for degree. Now degree is already highlighted here, so that's in the right mode. But basically, if you're not sure, if you want to double check, you can press enter on it, and that will make it highlighted. And then press second quick to go out. There's another way that we can measure angles, and you'll learn about that in pre-calc, called radians. But we're not going to be using that. We're just going to be using degrees, since that's typically how most people think of angles. All right, so we're going to type this in. We're going to type 11 times, and then right above here, you can see sine, cosine, tangent. We're going to press tan of 64. And that special number has all the ratios built into the calculator. It will figure it out, multiply it by 11, and there is our answer. So our answer to this problem here would be x equals 22 point, and we'll round to the first decimal place, 6. All right. So that's the length of this opposite side. All right, so let's do some practice problems and make sure we feel all right with this section here. All right, so for each one of these here, all right, circle the angle and label the two sides. Okay, this is the opposite and this is the adjacent. This is the hypotenuse, but it's not labeled, so we don't care about it. All right, so what trig function are we going to use with opposite and adjacent? Tan, just like we did in the last one. All right, so this be tan of 36 equals opposite is x, The adjacent is 7. All right, x is up high, we multiply. So the answer is going to be 7 times tangent of 36. And this is where it's nice to have a graphing calculator. We'll take that out. 7 times tan 36 equals, I got 5.1. So we're going to go ahead and write that down. All right, next problem here. Just keep this practice going here. You get to see all the different types of trig functions used, and you can see all the different scenarios that can happen. All right, so x is the hypotenuse. That's the biggest side here. This is the opposite. The adjacent isn't labeled. We don't need that. So SOHCAHTOA, some old horse caught another horse taking oats away. All right, what is that sign with the O and the H? That would be sine. So sine of the angle 63 equals opposite, which is 12, over the hypotenuse, which is x. Okay, if x is ever on the bottom, you're going to divide. So you're going to do 12 divided by sine of 63. Okay, so graphing calculator, super nice because of this. You're just going to type it in, 12 divided by sine 63. It does all the work for you. You're just going to round, and that would be 13.5. If you feel like you want to pause the video to try the rest on your own, feel free to do that and just move on ahead. But let's just keep going if you're feeling a little lost. All right, so let's label the sides. 32 is the hypotenuse. Over here's the opposite. That's the adjacent. We're not caring about the opposite at all. We just have the H trying to find the A. That would be cosine. So the cosine of the angles 41 equals A then H. So A is X, H is 32. In this problem, X is up high. If X is up high, we multiply. All right, so we're going to take out a graphing calculator. We're going to go ahead and look for that answer there. So 32 times cosine 41. Enter. We got 24.2. Man, every single one of these we've had to round up. Oh no, I cleared everything out. Oh well, we'll be good. Wrong button, I pressed but. Good thing we're recording this so we can go back and watch the video. All right, next problem here. All right, let's look at the angle here. This is the hypotenuse. There's the opposite. There's the adjacent. All right, so we don't care about the O. It's not labeled at all. We got A and H. SOHCAHTOA again. A and H. Okay, that's cosine. So the cosine, the angle's 29 equals A, which is X, over H is 29. X is up high again, so we're going to multiply. X equals 29 times cosine of 29. Go ahead, click our mouse, go through here. Oh, forgot the 29. So 29 times cosine 29. All right, 25.4 when we round up. Man, every single one we're rounding up. Oh, I already forgot what that number was. 25.4. All right, last problem here to wrap up these notes here. Let's look at this one. All right, 12 is the hypotenuse. X is the opposite. This other side down here is the adjacent. We don't care about that. We got H and O, which would be sine. So sine of the angle's 15 equals opposite is X over hypotenuse, which is 12. X is up high, we multiply. So 12 times sine of 15. Plugging this into the calculator. So hopefully now you guys can start to see a lot of this is just making sure we know how to use the right way so we can tell the calculator exactly what to plug in. The calculator does actually all the hard work. This one we don't have to round up. That's just 3.1. And so there we go. All right, so hopefully after watching this, you guys feel like you could now find the side or the missing side of any right triangle. Thanks for watching, and I will see you guys next time. Have a good one.